Section 6.3 is sampling, distribution, and estimate. Let's say there is a large city and we want to calculate or estimate average income of all the households. And we don't know what it is. But let's assume that it's $50,000. Now, to find this number, rather than find income of entire family live in this city, we could take a sample, equal samples. So we go to the different region of this city and we take, for instance, let's say we take sample of 20. From this corner, we take sample of 20 family and we estimate their average income. Then we go to the different side, different area, and take another 20 and another 20, another 20. If we take all these averages and divide it by number, let's say if you take it from 1, 2, 3, 4, 5 places or 4 places, we could find some of the mean and divide by that 4. That normally give you the number that we are looking for or a number close to that. As long as we take equal size samples, means if we take 20, we have to take 20 from each area. The sample size must be equal. So based on that, we notice that if we do that for proportion, mean, and variance, they all are almost the same. So here, proportion of population normally is equal to proportion of the samples. Mean of population is equal to mean of samples, means when you take a samples and take average of those are normally equal to mean of population, the same thing for proportion of the samples, and the variance. They call it unbiased samples. So unbiased samples or unbiased estimators are the one that when you take several samples with the same size and you calculate the proportions, that is normally equal to proportion of populations. But bias estimate, when we did a calculation for median, range, and standard deviation, they were not equal. So for these three, they are not equal. So for proportions, mean, and variance are the same. For median, range, and standard deviations are not the same. So they call it bias or unbiased estimate. So unbiased estimate is this three. Bias is median, range, and standard deviations. Now we do all this by example. We are taking, let's say there is a population that there are 3 numbers in it. So what we do is we have to do calculation for population, also calculation for samples. So let's say we have a population that there are 3 numbers in these populations, 4, 5, 9. Each time we want to take a sample of 2 out of these 3. So when you take sample of 2 out of 3, these are all the possibilities. If it's with replacement, it could be 4 and 4, means when you randomly select 1 out of 3, if it's 4, you put it back there, and the second one also will give you 4, so that's one option. Let's say the first one is 4, the second one is 5, that's the second. So you end up having 9 samples. So out of these 3 numbers, you could create 9 samples. Then for these 9 samples, we calculate a median. Median is the number exactly in the middle. If you have 4 and 4, the median is in the middle, which is also 4. 4 and 5 is 9. What number is between 4 and 5? 4.5. 4 and 9 are 13. Median is the number exactly between these two, 6.5, and so on. Range is subtraction of these 2 numbers. 4 minus 4, 0. 4 minus 5, 1. We don't care about the negative. We just find the difference. 4 and 9, what's the difference between 4 and 9? The small number, and the range is maximum minus minimum, so it would be 5, and so on. Mean is taking the average. What is the average of 4 and 4? 4 plus 4 divided by 4 is 4. 4 and 5 is 9. To take average divided by 2 is 4.5, and so on. This is mean of samples. For each sample, you find the median, you find the range, you find the mean, you find the variance, you find proportion of the odd numbers. Like between 4 and 4, I have two numbers, 4 and 5. What's the proportion of odd? 1 out of 2. Out of these two numbers, 1 is the odd number, so proportion is 0.5. Proportion is 0.5, 0.5. Or like 5 and 5. What's the proportion of odd? 2 over 2, or 1. Variance is a standard deviation to power of 2. And how do I calculate the standard deviation? You just take a square root of the variance, which is these numbers. So for the samples, when you calculate the mean for all these samples, when you calculate the mean, then you take the average of all this. Average of all this means you add all these numbers, which is 54 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 6. You also calculate the median. Median, again, you add all these numbers, is 54 divided by 9 is 6. Range, sum of the range is 20, divided by 9 is 2.2. Variance divided by 9 is 4.7, and so on. Now, these are for the sample. Now, there are two formulas. If you want to calculate the standard deviation of populations that we are using this symbol, is from this formula. If you want to calculate the standard deviation of the samples, then this is a formula to use. So they have a different formula. This is for a standard deviation. That's why I have S. Standard deviation of sample. This is standard deviation of populations. And then here, they show you how we calculate the variance. Like for the first samples, our first sample is 4 and 4. 4 and 4, there are two x's. X2 is this. Then you find sum of x2. Then variance, which is S2. What is the formula for variance? N sum of x2 minus sum of x2 power of 2. And n times n, we are talking about two numbers, 2 minus 1. So the variance is this 0 for these two numbers, for 4 and 5. What is 4 and 5? The second sample. The second sample is 4 and 5. For 4 and 5, we do the calculation for 4 and 5. Then the variance is 0.5. Then variance is 8 and 12.5. These are all variance for samples. So here I have sample calculation. So how to calculate the variance for the samples? This is the formula for each samples. 4 and 9, 5 and 9, 4 and 5, 4 and 4. Now, how do I calculate for population? Remember, population, there are only 3 numbers in it. So how do I calculate the mean? You take the average of these 3, means you add these 3 numbers, sum of those divided by 3 is 6. How do I calculate the median? What number is exactly in the middle? Is 5. Range is maximum minus the minimum, lowest and highest, 5. Variance for population is from this formula. Means you have 3 numbers, you raise it to power of 2. What is calculated? What's the probability? 1 out of 3. What's the probability of 4? 1 out of 3. Probability of 5. 1 out of they all have the same probability. X2 PX. Then you find sum of X2 PX, and you take all and you put it into this formula. So a standard deviation of variance of population is 14 over 3, or 4.7. A standard deviation is a square root of the variance, which is that number. What is proportion of the odd numbers? 4, 5, and 9. 2 of them are odd. What's the proportion of odd numbers? 2 out of 3. Okay, so now we do the comparison. For the sample, we came up with mean. For population, also mean. So you understand that mean of samples is equal to mean of population. The median for samples, I came up with 6. For population, I came up with 5. So median of the samples and population are not the same. Bias. Range are not the same. Variance are the same. When we calculate the variance for population and sample, they both happen to be together. Proportion of the odd numbers are the same. And standard deviation is not. So 3 of them with the yellow highlight means mean, variance, and proportion for the samples and population are the same. But the other 3 are not the same. This is a table at the end of the textbook that has all the formulas. So here, this is formula for populations, how to calculate a standard deviation of population. This is how to calculate a standard deviation of the samples. You see, they have a different formula. Problem number 1, I have the solution for you here. So there are 3 numbers, and these numbers are population, and there are 3 numbers, 2, 6, and 7. These are all the pairs, but because you take a sample of 2, means each time you take 2 out of these 3 numbers. So you create all these samples, okay? And then, so what we do is to calculate standard deviations for 3 numbers. The easy way is to use your calculator. Go to stat. First, put the edit. List is L1. So I go on my calculator and I put in those 3 numbers. So through the calculator, you put those 3 numbers, 2, 6, 7. You put those 3 numbers on L1 because you want to calculate a standard deviation of these 3 numbers using the calculator. You put everything on L1, then you go to stat and calculations, and then the very first one, default. Make sure this is L1. You have L1 here. So you see 2.16. Remember, this is for population. This is for the samples. Never mind this X. The sigma is a standard deviation of population is 2.16. Now they want us to do it for every pair, means just these 2 numbers, and so on. When you do it, the standard deviation is 0. Why? Because all the numbers are the same. So if you go and just put the same number, let's say you put 6 and 6, then you see that, let's say in L2, let's say I want to find 6 and 6. I want to find the standard deviation of 6 and 6. Okay, I go to L2 because there's no number here. 6 and then 6. Okay, and then I go to stat, calculations, first one. Now my number is in L2 this time. See, the standard deviation is 0. And then they are asking about the proportion. 3 pair out of 9 samples. 3 pair out of 9 samples is 1/3. And then you put all the numbers in order. I put the correct solution for you here. This problem is very similar to that, so it's a good practice for you, and the solution is here. It's very similar to that one. And the rest is all, I believe, is multiple choice. And I have the answer for those at the bottom of those, okay?